Morning, everyone. My name is Samir. Currently, I'm pursuing BTech second year at SRIT Institute of Technology. Today, I'm here to give my presentation, which is about how to choose the right clustering algorithm. So, without further delay, let's get into the topic. Introduction to clustering algorithms. Clustering is an unsupervised learning technique used to group similar data points. Choosing the right clustering algorithm is essential for effective data analysis. The choice depends on the nature of the data and the specific goals of the analysis. So as we can see in the picture, this is how the raw data gets into the algorithm and gets as an output, and also without any cluster. Understanding your data. Analyze the characteristics and structure of your data before selecting an algorithm. Consider whether your data is continuous, categorical, or a mix of both. The dimensionality of your data can also significantly impact the clustering approach. Types of clustering algorithms. Clustering algorithms can be broadly categorized into portioning, hierarchical, and density-based methods. Each type has its strengths and weaknesses depending on the dataset characteristics. Hierarchical clustering and portionizal clustering, as we can see in the picture, that's how it is. Portionizing methods. K-means is a popular portionizing method that minimizes variance within clusters. It requires the number of clusters to be specified in advance, which can be a limitation. This approach works best with spherical clusters and well-separated data points. So the hierarchical method. The hierarchical clustering builds a tree of clusters, allowing for different levels of granularity. It does not require the numbers of clusters to be specified upfront, offering flexibility. However, it can be computationally expensive and less effective with large data sets. So in the picture, that's how we are seeing. That is what density-based methods, also known as the DBS CAN, is well-known density-based clustering algorithm that identifies clusters of varying shapes. It is effective for data sets with noise, can discover clusters or arbitrary shape. However, it can struggle with varying densities within the data, which may affect the results. So, and evaluating clustering algorithms. So, use cluster validation metrics in Silford score and Davis Baldwin index to access quality. Visualizations such as scatter plots can help you understand the clustering results better. Comparing multiple algorithms on the same datasets can reveal the most suitable option. So scalability and performance. The scalability of an algorithm is crucial when working with large datasets. Some algorithms may computationally intensive and not feasible for big data. It's important to balance between accuracy and performance based on dataset size. So interpretability and usability. So sorting the algorithm section sort and to sort the data according to our needs. Consider how easy it is to interrupt the clusters generated by the algorithm. User-friendly algorithms can save time and effort in data analysis. Ensure that the algorithm aligns with the goals of your project and expertise of the team. So yeah, the conclusion and best practices. The right clustering algorithm depends on your specific data and project goals. Experimenting with multiple algorithms can provide insights to the best approach. Always validate results and be open to iterating on your choices based on the feedback and performance. So as we can see in the picture, the graphical representation is how a cluster plot and how a cluster algorithm works by varying the shapes of our data. So as you can see, the sphere, triangle, square, and plus and a box symbol is there on the graph, that how magnificently that it separated the different shapes, varying in their shapes and all the colors. So this is how the cluster algorithm works, and the algorithm depends on the specific data and your project goals. Thank you.